Okay, so say we're going to solve equations by completing the square. Okay, so we have done it last one with quadratic formula, depending on the order you're seeing this in. We've done it by factoring. Now we're doing it by quadratic formula. Quadratic formula always works. Remember, factoring sometimes works, sometimes doesn't. Um, complete solving by completing the square that we're doing right now, this always works as well. Okay, so step one in doing this. Right now it's in standard form. Remember, this is called a quadratic term because it's degree 2. It's called the linear term because it's degree 1. Okay, review vocab. It's called a constant term because it's degree 0. Remember, I can always put an x to 0 right there, so it's degree 0 because x to 0 is 1. And then 1 times 21 is 21. So when we're solving by completing the square, we want to get the quadratic and the linear terms, those that have variables in them, to one side of the equal sign, the constant or constants if there's more than one to the other. We want our leading coefficient always to be positive 1. It is positive 1 right here, so we leave it on this side. The constant then goes to the other side. So opposite of plus 21 is minus 21 subtracted across. Okay, that's our first step. Then step 2 says add in a blank to both sides. So that's this blank. Let me make it so you can see it again here. That's this blank right here and this blank right here. Okay, I'm putting it in standard form. Ax squared plus bx plus blank. I'm solving for this c. That's why you see the c right here. I need to fill in this c to make it a perfect square. Okay, how do I do that? It's 1/2 of b quantity squared. Remember, here's my a, here's my b. Coefficient of the linear term is b. Coefficient of the quadratic term is a. I do half of b, half of 10. That's a 10 right there. Half of 10 is 5. Put the sign with it. Notice when I identified the b here, I identified the sign or circle the sign as well. That's going to help you when you write the perfect square down below here. Okay, so half of b, half of 10 is 5. 5 squared is 25. That's why you see a 25 here. And why you see a 25 over here. Whatever I do to one side, I must do to the other side. That's why I had the two blanks in there. I'm adding numbers. I can't change the equation. So I got to, if I'm adding 25 to the left, I must add 25 to the right. So it stays equal. Okay, you've seen this over and over. All right, so now that's just a practice. Fire alarm, don't worry about it. They've already warned us. All right, so now here, this plus 5, this comes down into making this a perfect square. Pretend like this square root is not there yet. Okay, I just so you know why it's all written to begin with is because I had started the video. It said I was running out of space and paused the whole video, so I didn't want to erase everything and start again. So we would have this right here, and then since this is x squared, the square of that is x, and this plus 5 just gets dropped right down into there. So x plus 5 quantity squared equals this 25 minus 1 is 25 minus 21 is 4. And now it looks like what we did last section or somewhere around here, we took the square root of both sides. Remember how to get rid of this 2? I have to take the square root of both sides. So that's why I took the square root of both sides. And then don't forget it's a plus or a minus. Okay? Because there's two answers. Degree 2 means two answers. So now it takes off that, and I'm left with x plus 5 equals the plus or minus 2. Okay, well now I need to get rid of that plus 5, so I'm subtracting 5 from both sides. And then I just went ahead and rearranged and put the minus 5 out front and the plus or minus 2 second. And then I get negative 5 plus 2, which is negative 3, and negative 5 minus 2 is negative 7. So there's my two answers, negative 3, negative 7. Now, if I look back up here at the original equation, okay, notice I could have factored this nice and easily because that what multiplies to 21 and adds a 10, 7 and 3. Okay, with a leading coefficient of 1, nice and easy. And there you set each one equal to 0, and you get x equals negative 7 and x equals negative 3. So that would have been the quickest way. Quadratic formula, which we did last, would have been the longest way, and then completing the square like this is the second shortest way. As long as you can remember it's half of b squared, and then you make sure you take and add it to both sides, take the square root of both sides, put your plus and minus there, okay, then it's not too bad, okay? So there's that. Let's look at another one. starting from scratch this time. Okay, so I asked myself, are my quadratic and linear terms on one side and my constant on the other? Not quite. I have a linear term on this side. I need to move it over here. Remember, I want my leading coefficient to be 1. So that is 1. So we're moving everything, the quadratic and linear terms, to the left side. The constant stays to the right. So I have 1x squared. Remember, that's going to be minus 14x to move it across. So minus 14x. So that's going to be minus 24x equals negative, oops, I want to add in that plus blank, right? Plus blank equals negative 100 plus blank, because whatever I add to make this perfect square over here, which we know is 1/2 of b, quantity squared every time. And remember, you can go ahead and name your a and your b right there. So circle it with the sign. So I have 1/2 of negative 24 is negative 12 squared, which then is 144. Remember, notice I could always put a plus there because it always has to be a positive answer. When I square any number, it has to be positive. So that's why I could have already put in that plus. So I added 144 to the left. I must add 144 to the right. Okay. And then, oops, that was next squared there. I forgot to bring down. Okay. So then what perfect square is that? The only thing that multiplies to x squared is x. And then I just drop that negative 12 right into there. That's why it's important that you keep that sign with it, either whether it's positive 12 or negative 12. You're just going to drop it right into there. So what this is saying is x minus 12 quantity squared equals x squared minus 24x plus 144. Okay, I changed that to a perfect square trinomial. This is just the quickest way of doing that. So if you haven't tried to figure out what that factors into in that box there, I just showed you real quick. If you write down your steps here, you can just drop in that negative 12 and you're already done right there. So that equals 144 minus 100, which is 44. Okay. So now it looks like we had last section where we had to take the square root of both sides. Remember, I got to get that degree 2 down to degree 1. So how do I do that? I take the square root of both sides. Don't forget that degree 2 means 2 answers. So it's plus or minus on this side right here. Okay, and now I have x minus 12 equals plus or minus. I need to be able to reduce that radical. Remember, that is root 4 times root 11. Which one of those is a perfect square? Square root of 4. So that equals 2. Root 11 does not break down anymore. So it's just root 11 again. Last step, add the 12 across. Add the 12 across. So I have x equals 12 plus or minus 2 root 11. These are my two answers right there. Okay, this is what you would have got if you had plugged into the quadratic formula. Okay, it would have just taken more steps and reduce and making sure you can multiply right and reduce your radicals and all that kind of stuff. Okay, so let's do another type which is going to deal with this. I'm going to bring in now a geometry question with completing the square. You're going to do this next year in geometry. So I'm going to teach it to you now so you will be ahead of everybody. Okay, because most Algebra 1 teachers do not teach this, but this goes right along. You are completing the square here. You're just going to do it twice in the same problem. We just did it once. Now we're going to do it twice. The same rules apply. The same rules, no different. Instead of doing it one time only, like we just did in the last two problems, we're going to do it twice. Okay, so I want to line my, see, notice on the left side already, I started with an easy one. So you notice all my quadratic terms and my linear terms are on the left side. The constant's already on the right. If it wasn't, I would have to set it up like this. I also want to set up my x's together and my y's together. I've already set it up like that for you. Nice, easy one to begin with here. I still need to then go ahead and add in my plus c on each one of those. So there's my plus blank there. And then I have my y squared plus 10y plus blank for this one to complete that square. And equals 12 plus blank, whatever those two add up to, I have to add to the right side so I don't change the equation. Okay, what we're doing here, and you're going to do next year in geometry, is you're going to find the center of the circle and the exact radius from completing the square. So we're practicing it right now. So when you see it next year in geometry, go, yes, I can remember this. I remember doing this at the end of the year in Algebra 1. So again, it doesn't change. It's the same exact rules as I just said, 1/2 of b quantity squared. So what is, there's my b, circle it. There's my b, circle it with the signs. So what's half of negative 8? Negative 4 squared. What's negative 4 squared? 16. So that's going to be x, and then drop it down, minus 4 squared. Okay, half of b squared doesn't change. What's half of 10? 5 squared is 25. So this is now y, and then drop it down, plus 5, the sign goes with it, squared. Okay, so I've just done it twice. I've done the same thing twice. And I added 16. I'll change the color. I added 16 on this one and 25 on that for a total of 41. Okay, so since I added 41 on the left, I must add 41 on the right. So 41 plus 12 is 53. Okay, now it says, what's the center? The center is always the opposite here, and the square root right there. Okay, so the opposite of negative 4 is positive 4. The opposite of positive 5 is negative 5. There's my center. And the exact radius is the square root of 53. Now, if square root of 53 simplified, I would need to simplify it. It does not simplify. So I'm done. That's the exact answer. Notice it asked for exact. It didn't ask for round to the nearest 10th or 100th, or else I'd put it in the calculator and round to the nearest 10th or 100th. You always give exact answers unless it tells you to round. Okay, so let's do one more of these. Again, it's just completing the square twice in one problem instead of once. And then you just got to remember at the end, when it's in this is right here, it's called the standard form of a circle, just so you know. Okay, what's the center and the radius of the following circle? So that right there is the standard form of a circle. On the DCAS, you're going to do this on the DCAS. Okay, they're going to also give you one with the standard form, and they'll say, what's the center and the radius? You just look at it and do opposite, opposite, and square root. So remember that phrase as well, opposite, opposite, square root when it's in standard form. And I get my 4, negative 5, and square root of 53. Okay, let's do one more. Now notice this time, both the quadratic terms and the linear terms are not on the same side. I need my x squared, my y squared to be positives, so they're on the left side. So that means the linear terms now need to get moved to the left side, and that constant stays on the right. So I'm going to rewrite this now. X squared. How do I move minus? I'm going to do the x next because the x's go next to each other. How do I move plus 16x across? I subtract it, minus 16x plus blank because we're completing the square. Then I have my y squared. How do I move this negative 10y across? I add 10y across plus blank equals, that negative 12 is staying over here, and then plus blank, whatever those two add up to on the left, I have to add to the right. So that's now just the only new step. You're having to get the quadratic and linear terms to one side. Again, you see how you know your vocabulary, quadratic term, linear term. Remember, quadratic term are the degree 2's, the linear terms are the degree 1's, the constant is always degree 0. Okay, doesn't change, same rule applies, 1/2 of b, quantity squared, so half, I can circle that with the sign, half of negative 16 is negative 8, put it there, squared is 64, always a positive, okay, that's going to then break down to x, drop it right on in there, minus 8 squared, so x minus 8 squared equals that factored, that's the factored form of it, then I have my y, 1/2 of b squared, circle it with the sign, so half of b is positive, half of 10 is 5, squared is 25. Okay, now I can have y there, drop it right on down, plus 5 squared equals, how much did I add? I added 89, so I must add 89 over here to the right side. 64 plus 25 is 89. Add it to the right side, so I haven't changed the equation. So 89 minus 12 is 77. Okay, so now remember this is called standard form of a circle. Okay, and now they want the center and the radius. Remember it's opposite, opposite, and square root every time, doesn't change. So my center, C for center, Opposite is 8. Opposite of 5 is -5. It should be easy to recognize since the 8 is connected with the x, that's the x coordinate. The 5 is connected to the y, that's the y coordinate. And the radius equals the square root of 77. Now that does not break down, so it's done. How can I know it doesn't break down? Well, I know 7 times 11 is 77, and both of those are prime. Okay, so I can't break either of those down. Since I can't break either of those down, 77 doesn't break down either. Okay, so that's just a quick way to know that 77 square root of 77 does not break down. Okay, and there's my center and radius. So we're going to practice this. I'll put up some problems on the board as well. It's the same thing as if you did it with 1 completing the square. You're just doing it with 2 completing the square. It's the exact same rules apply. You're going to do this next year in geometry. It's going to be on the DCAS in geometry. You're going to be given to complete the square like this, and you're going to also be given this standard form of a circle right down here and ask you to identify the center and radius. And you have to remember opposite, opposite, square root, and do that 8, -5 for the center and square root is 77 for the radius. So you guys now are ahead of the game for geometry. There are many people that struggle in doing this in geometry, in completing the square, because several teachers don't get to it at the end of Algebra 1. Since I've been teaching geometry for years, I know how important this is, and that's why I'm adding this in right now and making sure we do completing the square, and then making sure we do this completing the square with the center and the radius. So you're already familiar with it when you see it in geometry next year. All right, that will end it.